This is Business Analytics using forecasting, and I'm Galit Shmueli. Now we're ready to start talking about some methods for forecasting binary outcomes. In the next two videos, we're going to look at logistic regression. Logistic regression is a cousin of linear regression that is specifically suitable for binary outcomes. In the videos on binary forecasting, I described three scenarios in which you might be interested in binary forecasts. While in some cases the original data might be binary, in other cases we might have numerical data, such as stock prices or blood pressure readings, which we convert into a binary variable of interest. The logistic regression model is suitable in all these different cases. We will again use the Melbourne daily rainfall example. This time we'll illustrate how logistic regression is used. Recall that for each day we have the numerical rainfall amount, and that we created a new binary column that has a 1 for a rainy day and 0 otherwise. When we explored the data, we discovered a clear monthly seasonal pattern, which appears to be captured reasonably well by a polynomial trend. It also smoothly transitions between months, so we could potentially use sine and cosine functions. As in linear regression, we first choose which predictors to use. Given the smooth seasonality, we can use sine and cosine functions to capture the annual seasonality. From domain knowledge, we suspect that neighboring days are likely to have the same rainy pattern. So we also choose to include a lag1 predictor. If this were a linear regression, we would write an equation similar to the one that you see here. In fact, if you try to run a linear regression, the software will most likely give you an output. Let's try and see. Setting up predictors for logistic regression is exactly the same as for a linear regression. This spreadsheet shows all the variables that I'll be using in the regression. The column rain will be the output variable, and for predictors, we'll use the columns lag1, seasonal sine, and seasonal cosine. Note that although in this example we're using a purely extrapolation model, where we only use past values of the series, a logistic regression can also include external predictors, similar to a linear regression. Here's the result after we partition the data, keeping the last 667 days in the validation period, and then we run a linear regression. We actually do get an output. We get a coefficients table, and we get performance metrics on the training and validation data. But let's look a bit more carefully at these and think carefully. What is the problem with using a linear regression? Why do we need a new method called logistic regression? We're going to answer that in the next video.